Hello, everybody. Welcome to our RagHack live streams.
RagHack is a free global hackathon happening from September 3rd to 16th. RAG is a technique to get a large language model to answer questions based off your data. We have more than 25 live streams teaching you how to build RAG apps with different Microsoft technologies, plus 10 cash prizes for the best RAG apps in each category. So we're super excited to have you join us for this RagHack. And now a word from our friends at Reactor.
Hello, everyone, and thank you for joining us for today's session. My name is Danny, and I'm the event planner for the New York Reactor space. Before we start, I have a few things to go over. Please take a moment to read our code of conduct. We seek to provide a respectful environment for both our audience and presenters. We encourage engagement in the chat, but please be mindful of your commentary, remain professional, and on topic. Useful links will be shared in the chat. The session is recorded and will be available on demand 24 to 48 hours on the Microsoft Reactor YouTube channel. Which brings us to today's session. It'll run for approximately 1 hour with time for questions throughout. I will now turn it over to our speaker for introductions.
Thanks, Danny, and hello, everyone. Good morning, good afternoon. Thanks for having me today at this RAG Hackathon event. My name is Davide Antelmo, and I am an App Innovation Cloud Solution Architect here at Microsoft, helping Java customer to unblock their Java workload in Azure. And in the last year, I've been having some fun with OpenAI and generative AI applications. So that's why I'm here today talking about how you can actually build a RAG application with Java and Semantic Kernel. So we are going to spend most of our time reviewing a Java end-to-end solution about implementing a chat with your private data. And so we will have some code walkthrough. However, before that, we will just review what are the main use case scenario and problems that RAG pattern solves, and also what actually RAG is, and what kind of building block you need to build a RAG flow. So large language models like the one provided by Azure OpenAI are known to be good at several natural language processing, like answering user questions based on their internal knowledge base. But this knowledge base is actually limited to only public internet data. So it's stale and it's not tailored to a specific domain or any internal company data, right? So for example, for a model like GPT-3.5, the cutoff date is like 2021, or for the most recent one, models like GPT-4 is about 2023, if I remember well. So to obtain an accurate and relevant output, we must provide the LLM with necessary information. And that's where RAG can help solve this challenge. And our focus for today's session is this chat with your private data scenario or use case category, specifically the chat with your private documents here. So basically you have a company with this large corpus of textual content like PDF, words, or content coming from their internal website like HTML, Markdown, and they want to use this corpus as basis for answer to user query in a chat-based application. However, RAG can also be used when you have more structured data like tables in your database or data lakes or business API. Specifically, we are going to see how to use Java and RAG to implement a chat hub application that help employees to answer questions about a fictitious company, policies, job role description, and benefits plan. So this is a common scenario that has been implemented in Microsoft in different languages. And it is publicly available as AI App Template Initiative at this link here, aka.ms/AZAI. And specifically, the Java implementation is on GitHub under Azure Simple Organization, and that's called Azure Search OpenAI demo Java. So I've actually prepared a demo environment for you today. So because I want to show you some user interface capability and features, so you can later connect to the code that we are going to review. So let me switch to my demo environment. Okay, perfect. So it's basically a chat-based application, right? That has been preloaded with these documents, PDF about the company benefits plan, employee job description. So, for example, we can start asking a question about this topic. So we can go for one of these suggested questions here. So what does a product manager do? And hopefully get an answer in a few seconds. Perfect, it's coming. So a product manager is responsible for leading the product management team and providing guidance on product strategy, design, and blah, blah, blah. It looks enough good. And one thing that I want to let you notice here is that along with generated answers, we also have citation here that have been used, which actually are document search results from Azure AI Search. And you can actually double check into that and see what is the specifically PDF page that have been used to actually generate this answer. And you also have another tab here, supporting content, which actually lists all the sources that have been used, or the LLM has to actually generate the answer, but sometimes it can actually go for just one of these text chunks. And also you have a thought process tab where you can actually review what is the prompt that has been sent to the chat endpoint, and also all the sources within the prompt, which are actually part of the prompt of the chat endpoint input. Another thing that's interesting to see here is that it actually remember the chat conversation, the chat topic that you are discussing. So for example, if I ask how many work experience are required without mentioning role, we should expect the answer to actually remember that we are talking about the product manager role. Perfect. And so this is not actually coming out of the box from a large language model, because large language models are stateless. So this is something that you actually need to implement your chat application. And finally, you have here the developer setting panels at your top right, where you can tweak some parameters. Like we will see, we have two Java implementation approach, the plain Java implementation and the Java semantic kernel that you can select at runtime and compare. What else? You can actually set the numbers of search results here, or you can also, for example, set the type of documents retrieval approach. We have hybrid, we have vectors, meaning semantic search or full text search. And we will talk more about that later. So let's go back to the presentation. So the Azure AI Java app template comes with different architectural style and Azure hosting option. We have app services option, where actually you have app front-end and back-end co-located within the same Spring Boot app application, and integrating with and talk with Azure AI Search, and orchestrating and generating the answer using Azure OpenAI. Actually, the sample app has been tested with GPT-3.5 Turbo, but one of the models that you can actually use is, for example, the GPT-4o Mini. And there is also an document indexing part here, which in this option is running locally on your machine. Or you also have a more microservices event-driven architecture. And in this case, you actually have 3 microservices, one to run the user interface, another one to add the Spring Boot application implementing the chat flow, and another one running actually the indexing flow. In this case is on server side. And more or less, the architecture and the components is the same. So you can actually, it's the same in Azure Kubernetes Service. So you can actually run the solution as a microservice architecture or Azure Container Apps and Azure Kubernetes Service. So in an event like an hackathon, for sure the app service option is simpler and cheaper option. You have to start exploring the code and RAG pattern. However, as the app code is shared across the different hosting option, it should not be too hard to actually switch to a more scalable and distributed architecture like the one in Azure Container Apps and Azure Kubernetes Services, if you want to do later. So, for example, it could be useful to use them if you have hundreds or thousands of documents that you want to ingest into the overall RAG flow. So how you can get started with this Java App Sample? 3 options. The first one is GitHub code spaces, really simple. You go to the to GitHub, fork the repository, and hit the code green button. And then after the code space section, you hit the create code space. So nothing to install locally. Or you can add, you can run it within Visual Studio Code with dev container extension. So again, you fork the repository, clone the repository locally on your machine, and you actually need Docker Desktop installed here. Or the third option is actually running a traditional development environment on your laptop, machine, or virtual machine, or whatever. And in that case, you need to install all the required dependency here. And after that, you pick one of the hosting option. So you move into deploy/ACA folder or deploy/AKS or app services, and has these sample app as infrastructure resources and application build and deployment fully automated through a tool called Azure Developer CLI. You can actually find these 2 commands here, azd out login and then azd up. And you will really quickly start exploring the demo and code. So let's talk about a little bit of what actually RAG is. And first, let's see from a developer perspective, from an app consuming perspective, what it means to actually integrate and work with an LLM model. So basically, you have this big pre-trained model like GPT-3.5, Turbo, or the most recent one, GPT-4o or GPT-4o Mini, that you can host in a cloud like Azure OpenAI, or you can also run them locally on your laptop, but it will consume a lot of your CPU and GPU. So for production scenario, you actually need to host them into a cloud option like Azure OpenAI, but you also need an endpoint to actually integrate and talk with them and leverage their capability. So for GPT-like models, you have an endpoint called Chat Completion API. For other model like Ada, you have another type of an endpoint, which is called Embedding API. And we will say in few seconds why this is relevant implementing RAG. So the Chat Completion API is really simple. It's a text in and text out. And a text in is called a prompt, which is basically a text string formatted as a list, as a chat with a list of messages. And then you get as an answer the generated text from the LLM. Instead, the embedding API is a text in and returns a list of vectors of floating point numbers called embeddings, which actually represent the semantic meaning of the input text. So large language model knowledge, as I mentioned it earlier, is limited to the data it has been trained on. So RAG is used to make LLM aware of domain-specific knowledge. So in other words, it is a way to find and inject relevant pieces of information from your data into the prompt before sending it to an LLM. So this way, the LLM will get, hopefully, relevant information based on a specific user question, and will be able to reply using this information and reducing the likelihood of hallucination. So about the retrieval system here, so relevant pieces of information can be found using various retrieval systems. So you have the full text keyword search, and this method search document by matching the keywords in a query, like what the user is asking, and it's actually matching the keywords against the database of documents, and it ranks results based on the frequency and relevance of these keywords in each document. Azure AI Search, for example, is traditional implement this search approach. There are other open source one like Elasticsearch. Then you also have vector store or semantic search. So in this case, text documents are converted into vectors or floating point numbers using embedding models that we have just mentioned. And it then finds and ranks document based on the cosine similarity or other distance measure between the query vector, and the document vectors. And again, example of system implementing semantic search. Again, Azure AI Search enable semantic search. There are some other open source options like Redis Search or Pinacon or Quadrant or pgvector in Postgres. And also a third option you have for the trivial system is the hybrid search, which basically combine the full text search and the vector search, usually improving the accuracy of the search result. And then finally, when you have your search result, as I said, you need to inject the search result into your prompt and orchestrate a couple of LLM call in order to get the answer. However, retrieving data also involves indexing them to make search easy and more accurate. And when working specifically with private documents, there are some challenges that you need to solve. So first of all, you need to move those documents on cloud storage, like Azure Blob Storage. And then you also need to start parsing those documents in the cloud. And so you will need data loading or data parsing or data parsers specifically for each document type, like, again, PDF, Words, PowerPoint, HTML, whatever. In some cases, you may also need a more accurate way to extract the text using tools that provide you OCR capability. So for example, in our example, we will see we are using Azure Document Intelligence to extract tabular data within PDF or within images. And once you have text extract from your document, you actually need to split them in text fragments. And you do that for two reasons. So the first one is that LLM have what is called a limited context window, meaning they accept a limited number of characters or tokens. And the second reason is that the more fine-tuned and specific text chunks will allow you for a more accurate search results and a better generated answer. So once you have your text chunks, you actually need to create embeddings out of them, because we need to enable the semantic search. And you actually need an LLM model like an embedding model like ADA2. And basically, you then store both your embedding and your text chunks into your index. Okay, so let's have a deep dive into the implementation. So implementing reg building block yourself can become quite complex, because you have seen you need to deal with different pieces. So you need to orchestrate different LLM models like GPT-3.5 or GPT-4 or embedding model. In some cases, you may want also to experiment with other open source model like, I don't know, LLama or Phi3. You'll need a prompt templating engine because at some point you need to inject your data into your prompt template. You need to generate embeddings, store embeddings, and run a semantic search. With chat with your private documents, you will need document loaders, document parser, text chunkers, and with the most recent advanced RAG techniques, you may also need from an LLM more reasoning and planning capability like agents or function call. So you have a lot to deal with, right? So this is where actually semantic kernel can help to flexibly integrate AI services into existing apps, simplifying data grounding and orchestration logic, reducing boilerplate code, and provide the production-ready pattern to integrate OpenAI. It's an open source Microsoft project. It has implemented different languages, C# on .NET, Python, Java. There are other popular AI orchestrator framework like LangChain in Python. There is also a LangChain version for Java, and for Java we also have Spring AI. So working with semantic kernel, basically you have this central object, which is called the kernel, and in its simplest form, you can think of it like a dependency injection container that orchestrates two elements, AI services and plugins. So AI services provide you common abstraction and interface for LLM models. So you don't need to go too much deep into the interaction implementation or specific LLM implementations. And it also provides a cross-cutting facility like error handling, telemetry, resiliency pattern, monitoring, and so forth. And then you have plugins. So plugins are semantic kernel units of work, basically encapsulating prompts and chat endpoint interaction. And you may also, we will see also how through plugins you can actually extend semantic kernel capability with your custom Java code. The Java AI app template that we will see today, it comes with two implementation. There is the semantic kernel implementation. It's the one that really simplifies AI orchestration. It has it provides built-in implementation for RAG building blocks. But if you are interested to look at generative AI and RAG application from a more low-level perspective and want to understand what's happening behind the scene, or if you have more specific requirement like streaming support, so in that case, it is worth to have a look into the plain Java implementation in the repo, which is basically it's based on the Java OpenAI Azure SDK and also the Azure AI Search SDK as well. But be prepared to review some boilerplate code here. Okay, so the project structure. So you basically have the app folder that contains the app code. Then you have the deploy folders containing the infrastructure code. So we are using Bicep, which is a specific Microsoft DSL, which simplify Azure resource creation in a declarative way. And then we are also using Azure Developer CLI, which automate infrastructure creation on Azure and also application build and deployment. In this folder, we also have script to triggering the indexing flow. In the app folder, we have a subfolder for the specific backend components. So we have the chat flow within the backend folder implemented in Java. We have the front-end folder containing the chat user interface. We have the indexer folder, which implement indexing flow in Java. And then in deploy folder, we have app service folder. With this option, as we mentioned earlier, we are going to run a one Spring Boot app which is based on Spring Boot 3, where you have front-end and back-end collocated on app service, and indexing your document indexing process is running locally. Instead, you have the two microservices option into the ACA folder or AKS folders. In this case, you will end up with three microservices, one running Nginx web server and actually running the user interface. And then you will have two Spring Boot apps, one from the chat flow and another one for the indexing logic. And then you have the data folder, right? So this is where we have put our fictitious company PDF documents representing company policies or benefits plan. And that's actually the folder where you can put your custom documents and actually start to asking questions about topics contained in this document directly into the user interface once you actually run the indexing process. So let's see how you can actually implement the RAG chat flow. Remember, we have the chat flow and the indexing flow. And in the chat flow, we need to retrieve relevant information based on the user question, and then you need to inject them into the prompt and call OpenAI to Azure OpenAI to generate an answer. We are going to focus more on the backend code today. However, just let me give you some highlights about the user interface. So the chat user interface is implemented as a single-page application in React and TypeScript. And what happens is that every time you hit the ask button or chat button into the user interface, you actually send the whole conversation within this object, chat app request, and it gets basically serialized as a JSON object, and the chat endpoint on the backend gets called. And everything and all the integration between front end and backend is into this central file called api.ts. On the backend side, the API chat is implemented using the Spring MVC framework. So we have this class chat controller annotated with REST controller annotation, and we have implemented two API, two chat endpoint here. So we have the streaming version. The whole head is the same, but the media type is application ending JSON, which stands for new delimited JSON. That's a kind of a different way you can deal with text chunks that you can send within a long-running HTTP connection. It's a little bit different from server-side events or WebSocket. And typically on the front-end part, on the JavaScript part, you need to deal with the readable stream instead of event interface. However, we are not going to look into that today, because we are going to look into the synchronous implementation of the chat endpoint, which has the application JSON as media type, because this is not yet available in Semantic Kernel, and we will focus more on that today. If you are interested in to see the streaming implementation, you can actually review the plain Java chat approach Java class. Okay, so with Semantic Kernel, as we have said, you need to orchestrate plugins. Actually, you need to orchestrate functions. So plugin is a collection of functions, and you have two types of function. You have semantic function and native function. So semantic function is a way where you can actually encapsulate the prompt and the integration with your LLM model through an external file, typically a YAML file. You can put it everywhere. In our use case, we prefer to map the function and the plugin in specific folder. So in order to implement the chat RAG flow, we have created an answer conversation semantic function, which has a specific YAML file configuration within answer conversation folder under the RAG folder, and also the extract keyword semantic function. And we will talk more about this later. And again, this is not something that Semantic Kernel is forcing to you. but that's more a design choice here. And we also have native function. So native function is a way you can actually extend semantic kernel capability with your custom Java code. And we are going to show you how you can implement the retrieving part using Azure AI search through semantic kernel native function. And basically, a native function is a Java plain class, but with some semantic kernel annotation, like define kernel function that you put on the public method and kernel function parameter that you use for each method params. So semantic kernel knows when and how to orchestrate these native function. So in order to implement the chat rag flow, we have created this answer conversation semantic plugin, and it actually uses a YAML file, and the template engine is handlebars. So handlebars is like an extension of Mustache, which is a template engine popular in the JavaScript landscape, and it provides capability like template parameters replacement or loop, so you can loop through your list of objects, or you can make your template more dynamic using conditional logic, or you can actually also call directly semantic kernel plugin in a declarative way from the template. I think that's better to jump directly to the source code here. So let me switch to the semantic configuration. So we have, yeah, that's the YAML file we have. So it's basically, it has two sections. So the first section is about configuring the prompt template. So you have the name, description, the actual template, and you also need to provide metadata about the variables that you are going to use within the template. So for example, we are going to inject the sources. We did the prompt template, and you see here we have used the sources variables here and using some handlebars expression language to loop through the list of sources. And the other section of the YAML file is these execution settings, where you actually you are going to configure the chat endpoint call parameter. So you have things like max tokens or temperature or top P. So yeah, so these are the kinds of parameters that you end up configuring with integrating with OpenAI. So about the template here, we don't have much time to go deeply into the prompt engineering style. However, in the prompt template, what we do is actually define a system message which provide instruction to the model about what is the expected behavior. So for example, we are saying here that we expect the model to answer the question only using the relevant information. We are also providing instruction about the output format. So remember the citation in the user interface. So basically, we also need a way to tell the LLM to provide reference citation in a specific format, so we can actually extract them and parse them into the response. And we are saying here that we expect into square brackets. We also have some other dynamic parts here, like this one. If the Boolean value called suggestion is true, we are also actually asking to create follow-up question here. And again, this is an helper from a handlebar expression language. We are using the if helper here. What else? We are providing a list of what is called few shot example to better explain to the model what is the expected answer. So we are providing a couple of examples as a list of user and assistant messages here. And at some point, we are injecting the document source within the prompt. And we see we have these each statement here, and we are creating, we are injecting the source into the user messages, and it contains a username, column, and user content here. And there is also another part here. Remember when I was talking about the chat to be stateful and able to remember the topics of the whole discussion? The way that you actually implement these is passing the whole conversation within the prompt. And obviously, you need to be mindful about the token limit here. So you need to check if you are actually you are hitting the token limit every time you put the whole conversation. So you need some techniques to actually check that. And finally, we are sending the user question as the last message here as a user message. Okay, so let's switch back to the slide. So we have seen our prompt, right? And we now need to understand how we can search for relevant documents based on the user question, and how we can actually also create embeddings from these relevant documents in order to enable semantic search. We have done this into a specific class called Azure AI Search Retriever, and it allows you to search using different methods here: text, vectors, and hybrid search. It takes care to actually create embeddings for your text chunks. And one thing that I want to share with you before going directly to the code is that it has implemented is a plain Java class without using a built-in vector store coming from semantic kernel for two reasons. The first one is that this class is shared across the plain Java implementation and the semantic kernel implementation. So we didn't want to introduce semantic kernel dependency here. And the second reason is that we wanted to showcase a way to use native semantic kernel native function. So yeah, if you want to simplify this implementation, you can actually use the built-in support provided by semantic kernel through the vector store interface and the specific Azure AI Search implementation. It is still experimental, but it works, so it is good for an hackathon. And it will actually simplify a lot the implementation. So let's have a quick look at the Azure AI Search retriever code. Okay, perfect. So the method that we are interested in is this retrieve from conversation public method that takes the whole conversation in this object. Let me actually zoom a little bit. The chat conversation object, and also the RAG option that we have configured into the user interface. And actually, as I said, we need to search relevant information based on the topics discussed within the chat. But you can actually send the whole conversation as Azure AI Search parameter. So what we do here is creating an additional call to Azure OpenAI in order to extract keywords from the whole conversation. So here we are preparing a template, and this time we see we have a simple class which implement the system message and the list of message as a list of string, and it takes care of also the replacement, the string replacement, and also you can see here this is not implementing with semantic kernel, and you can see that the boilerplate that you need to deal with when you are not using semantic kernel YAML file configuration. So once you have your prompt template in your Java class. Then you set some parameter here, like again, the temperature top P parameter that are the traditional ones that I use in my samples, and then actually use the Azure OpenAI client and the chat endpoint to extract keywords. So we get a chat completion object and then scan from for the last message in the chat completion and save the keywords within this last message here in this class. And then what we do with these keywords that we have extract. So basically, if we are going with the vector search or hybrid search, as I said, we actually need to convert these keywords into embeddings in order to enable semantic search. So we are doing an additional call here to the embedding model. And again, we are using Azure AI client. We are calling the get embeddings method here, passing the list of keywords, and we get the vectors as a list of float object here. And once we have this embedding object, we are starting to prepare the request for Azure AI search. So, for example, let's see what we do into these set search options for hybrid. So we actually deal with this Azure AI search class called search options. And what we do is actually set within this search option, we set the vectors parameter, providing an instance of the search query vector. And as part of the search query vector, we are setting the list of the embedding here, set value. We are also set the expected number of search results with set key nearest neighbors count. And you also need to tell Azure AI search what is the field names that contains the documents embedding. And we are saying here that the field is called embedding. Really fancy. So once you have your search options prepared, you actually use the Azure AI search client and pass both the keywords and the search options, because you need to enable the hybrid search or semantic search. So you will need both. And you actually get an iterable list of search of documents. And let's see what we do with this search document. So we iterate through this list of search document, which is basically a map in Java. So you have get methods. And we basically create a custom object called content source that simply have the source name and the text chunk. And we are simply calling the get method. So we are not just taking the text chunk as a search result here using this content field, but we are also retrieving and store some metadata fields like the source page. And this will be useful if you remember into the user interface in order for the user to double check what was the PDF page that have been used by the model to generate the answer. And basically, I think we are okay with this class. So let's switch back to the presentation. Okay, so a semantic kernel, it's still not aware of this logic. So in order to make semantic kernel orchestrate this retrieval logic, you need to use, remember, some annotation. So the define kernel function on top of the public methods. and the kernel function parameter for each parameter that you have. And we have created a specific class called Azure AI Search plugin. Again, this is not forced by Semantic Kernel. We just wanted to have a specific class for a plugin. And you can see here that we have just duplicated the search from conversation method from the Azure AI Search Retriever class. And we simply put the define kernel function on top of the public method, providing the name of the function, search from conversation, the description, and the description of the return type, which is the content source object that we have just created from the search results. And also, we are passing the overall chat conversation, and we are annotated these with the kernel function parameter, again, providing the name of the conversation that will be used by Semantic Kernel, a description, and the type of the input parameters. And besides some object transformation that we are doing into this line of codes here, we see what we are basically doing is creating an instance of Azure AI Search Retriever here, and passing the Azure AI Search client and the Azure AI client, and basically call the retrieve from conversation object, passing the whole conversation and the RAG option that we have initialized within the Azure AI Search plugin construction. So it's really simple to actually extend and promote a Java class to the semantic kernel context. Okay, so once you have all the plugins and function defined, you are ready to implement the RAG flow with semantic kernel. And basically, you need to create the central kernel object. And then you start to use this kernel object to sequentially call the plugins that you have defined. So this is an imperative approach to implement RAG. There are some other approach leveraging more advanced planning or reasoning feature from LLM like function call or planner. But I think for RAGs, try to stay simple and just because you already know what are all the predefined steps that you need for RAG. So having a simple imperative sequentially called lines of code, it's really simple and maintainable and more deterministic. So let's actually jump directly to the source code here. And we have implemented the chat flow into the Java semantic kernel chains chat approach here. And the method that we are interested in is this run public method. And I'm not going to talk you about all the layers that there are between the chat controller implementing the chat endpoint and the run method here. But assume that at some point within the call stack, this run method gets called and passing the whole conversation and the RAG options. Again, they are the option that we have configured into the user interface. So first of all, you need to build the kernel object here, and so we have done this into a specific method. So first of all, we need to abstract the interaction with an LLM model, and semantic kernel has this common interface called chat completion service. And as we are using Azure OpenAI, we have this OpenAI chat completion class with an handy builder. So you need to pass an Azure AI client and also the deployment name that we have used in Azure OpenAI service. Then you call the build service. So that's very, very simple to actually get an instance of a completion service using semantic kernel with OpenAI. And obviously, of course, there are other implementation for other models supported by semantic kernel. We need to actually create the definition for our plugin. So here we are creating the definition for our search from conversation function within the information finder plugin. So we are using this kernel plugin factory object with these using a create from object method. And we are simply passing an instance of the Azure AI search plugin that we have just mentioned. And it returns an instance of the kernel plugin. And then we remember we also have the semantic plugin called answer conversation within the RAG plugin. And again, we are using the kernel plugin factory. And this time we are using the create from function method here. And basically, we are passing the file path to the configuration file, to the YAML file for the semantic function. And we are also saying that we are using the handlebars template engine. So we are providing an instance of the handlebars prompt template factory here. Okay, so, and now finally, you need to create the kernel. And you use the builder helper here from the kernel object. And as I said, you pass the an AI service, passing the chat completion service, and then you set the search plugin, the answer plugin with this method here with plugin, with plugin. It's an Fluent API. Then you call the build method here. And okay, we are doing an additional things here. So semantic kernel also have this concept of hooks, where you can provide custom call that gets called for you within semantic kernel internal life cycle. So we have defined here what is called a pre-chat completion hook, actually, because we wanted to the whole prompt that we are going to send to send to the chat completion. So the whole prompt with all the sources, with all the conversation. And we want that within this class field here that's called rendered conversation. Okay, so we basically return the kernel here. And once we have the kernel, as I said, we first invoke the search conversation function using the semantic kernel. So we call invoke async with plugin name and function name. We provide the whole conversation as a function parameter here using kernel function arguments, set the return type as a list of object. And as this is a reactive API, which is asynchronous, we are calling the block method here to make it synchronous. And finally, we actually call the answer conversation semantic function here within the RAG plugin. And again, we are using the kernel object, invoke async with plugin name RAG, answer conversation as function name. We are passing we need to pass several arguments and variable value to the semantic plugin. Remember the metadata, the prompt template, the prompt template parameter that we have defined here into the YAML file. So we had the input, sources, conversation parameters. So basically, that's the list of variables that we are setting here using the search results. And yeah, so basically, again, we are invoking here the answer conversation function, and we are store the value into a function result with the string type, and we are creating this RAG response, a little bit complicated object RAG response, which basically store the generated answers along with some other useful information like the rendered conversation, the rendered prompt, and also the list of all the search results in order for the user to actually double check them into the user interface. Okay, good. So this was the implementation of the chat reg flow. Okay, so we have about 5 minutes. So I will try to condense into these 5 minutes how you can actually implement the indexing flow. So, okay, so let's start. So, so the indexing flow is triggered through a command line, and we actually used a tiny Java library called PicoCLI to implement this command line. And there are some scripts that you can use to actually run that command line within the deploy /app services /script folders, and the scripts are called prep docs. And you also have shell scripts or PowerShell scripts. And actually, the command line is used also for the app service hosting option, and also for the microservices Azure Container Apps or AKS option. And basically, for the app services, it takes care of the all indexing flow within this command, which is called add command. Instead, for the microservices approach on AKS or ACA, we use a different command, which is called upload command, that we are not going to see today, which basically upload the file to blob storage so they can get processed by the indexing logic running on the server. Okay, let me switch to the CLI object. Okay, so in PicoCLI, in order to create a command line, you actually create a simple Java class, implementing the callable interface. Then you have, obviously, you need to implement the call, but actually the main part is that you, in your main method, use the command line object here, passing an instance of your class, and then run an execute method, which basically scan your class for all the method, public method annotated with the command annotation here. And for and you see we are using basically the specific add command here. Let's jump into the implementation here. So what we are doing here, first of all, this add command need to deal with Azure AI Search. So we have a search index manager class. We need to deal with blob, Azure blob storage. So we have a blob manager client here. And then we have a document processor class that we have created to actually simplify the orchestration logic. So within the run method here, we basically first create the index into Azure AI Search if it doesn't already exist. So we are using the Azure AI Search client, and basically we are setting a couple of fields within the index, the ID, the content field containing the text chunks, the embedding fields that we have seen, and also some metadata like category, source page, and source file. So then what it happens is that actually scan your local folder. In that case, it's the data folder, but you can configure that. And so we actually run this method here for each PDF file within the data folder. And at some point, it passes this file to the index document from file method into the document processor, and which actually contain all the indexing logic. And after that, we basically upload the PDF document to blob storage, so it can again, we can actually implement the PDF viewer within the user interface. So really quick, this document processor class that we have created, the main method is index document from byte. So it takes as an input the array of byte representing the PDF file. So it tries to extract text based on a PDF parser. And we actually have two implementation here. The document intelligent PDF parser, which is the default one. As I said during the presentation, Azure Document Intelligence allows you to extract text in a more accurate way. So for example, if you have images, if you have tabular data, it is really, really recommended to do that. So for example, into the benefits plan documents, we have different plan compared into a table. That's why we are using this implementation here. But if you just have text documents without any image or tabular data, you can also switch the implementation to the iText PDF parser that actually runs locally within your JVM. So you will save some money and reduce the latency because there is no external dependencies. Then we actually, when we have our text extracted as a list of pages, we we actually split these pages in text chunks, and we have this class called text splitter, call this method split page, and it basically implement what is called an overlap text chunk. So for example, has parameter to set the maximum length of the section, and also the section overlap, meaning in order to avoid losing context when split a page in smaller chunks, you actually want to preserve some text from the previous chunks. So basically here, what we are saying is that we have a section which is 1,000 characters, which contains 100 text from the previous tokens, basically. So that's what we are saying. And what this method is doing here is basically try to split text based on the sentence endings or word breaks. And it also takes care if you have tabular data that have been formatted in HTML tables, to also avoid to split your data and your table in the middle of the HTML tables. So yeah, we have all logic to actually do that. And finally, once we have our list of text chunks, we actually need to create embeddings with them and update the index. So we need to call the update content method here on the search index manager. And again, we don't have too much time. Actually, we are running out of time. So really quickly, what we are doing here, we are actually arrange our text chunk into batches for performance reason. And we are creating an Azure document, a list of document where we are putting batches of document where we are putting for each document the ID, the content. We are setting some metadata like the category, the source page, and the source file. And actually, we need for this specific document the related embedding. And that's why we are calling here an embedding services using the batch style API, and actually set the embeddings that gets returned by these embedding services within the embedding field related to this document here. And then finally, we are uploading the document to Azure AI search here. Okay, perfect. So that's all for the indexing part. So, okay, so you have all the information here in the slide. I will leave you with all the pointer to the specific class. And one last thing I want to say. So if you want to start to put your custom PDF, you can actually move your documents within the data folders. And remember, this is not a Delta process. So every time you actually put the new files, all the files within the folder get indexed. And yeah, and if everything is successfully indexed, you should see something like that in your console or in your streaming platform in the cloud. And I will leave you some useful resources if you want to dive deeper into best practice for chunking or retrieval augmented generation or Azure AI search. And that's all today. Thanks.
Hi, everyone. Hope you enjoyed today's session.
If you aren't registered yet for RagHack, you can register now at aka.ms/raghack/register, and you can introduce yourself on our forum. You can start hacking either by looking at one of our code samples or just starting from scratch. If you have any questions along the way, feel free to post them in our GitHub discussion forum, and you can also attend live office hours in our Discord. Once your project is ready, make sure to submit it before September 16th at 11:59 p.m. PT to be eligible for our cash prizes. And of course, make sure to join our upcoming live streams to learn more about RAG. Thanks for joining.